So we're going to look at investments. And the first word that comes up is this word of annuities. So here's what we're going to assume. We're going to assume we were going to put a constant amount of money away at the end of each year or at the end of each month. And we're going to assume that we get a constant amount of interest each year, each month. Okay, so it's not very much different from the previous chapter where we talked about interest, except instead of having a lump sum that gains interest every month, we're going to put more away every single month or every single year. And we're also going to assume that interest is compounding at the same rate I'm adding to the annuity. So if I add to my annuity each year, then it's going to compound yearly. And if I add to my annuity each month, then it's going to compound monthly. This doesn't have to be the case in real life, but it makes the calculations a lot nicer. And especially when we talk about loans or some sort of a bank tool, that's really what's going to happen. So let's look at an example. And first off, we're going to assume a person puts $1,000 away at the end of each year for 3 years. And we're going to assume that person gets 5% interest. How much money should they have at the end? So I'm going to draw a quick diagram of what's going on. All right. So basically we have 3 years. So I'm going to draw a line representing those 3 years. All right. So this is year 1, year 2, and year 3. So what we're saying is at the end of year 1, I'm going to put $1,000 in. And then that $1,000 is going to accumulate interest until we get to the end of year 2. Now, at the end of year 2, I'm going to put another $1,000 in. And that's going to accumulate interest. Now, notice that my first $1,000 that I put in at the end of the year 1 is going to accumulate interest for year 2 and year 3. My second $1,000 only accumulates for year 3. My third one, and final in this case, $1,000, doesn't accumulate at all. Okay? Now, if we were in the previous chapter, what we would have to do is we'd have to look at this as essentially 3 different investments. And so if we treat those 3 amounts as 3 different investments, then the first investment, remember it was $1,000 at 5% interest. This was yearly interest. And it accumulated twice because for the sake of year 1 year 1 it didn't accumulate, but at the end of year 1 it was put in. So for year 2 and year 3 it accumulated interest. So the first investment would bring $1,102.50. All right. The second investment, this one came at the end of year 2, so it would have only brought 5% one time. And that investment brings you $1,050. The third investment doesn't accumulate interest at all, so it's just the $1,000 we put at the very end. So what you see here is that the total amount of the 3 investments, if we calculate that, is $3,152.50. So after 3 years of putting in $1,000 at the end of each year, you would have had $3,152.50. So in this slide, it's just the total sum of the three investments. We already said this. Now, I want to point out that what's happened here over 3 years, we could do. We could do that with a lot of different cases. But if I tried to do that over 15 years or 60 years, you see that that's a lot of things to add up. So we would kind of like to have a shortcut formula that would be able to get us to our end result a lot faster. So let's examine how we calculated that annuity. Now think about this. This was in our previous example, we had 1,000, 1.05 to the 2. Remember, our previous annuity was 3 years, plus 1,000, 1.05 to the first, plus 1,000. So basically, we're going to take each one of those payments, we're going to multiply it times some 1 plus a percentage rate. And this was 3 years. So we started at 2, compounding for 2 years. And then we added payment times interest rate for 1 year. And then we did that all the way down until we got to the actual last payment. That last payment was, in our case, $1,000. That's what this P stands for. Okay? And like I said, there's a lot of addition here. And so as the sums grow, if you had, 19 or 370 for your N, it's going to get really big and out of control. So here's how we transition that. Here's how we transition from a lot of sums to a more simplified approach. So it turns out if this is a formula, this x to the n minus 1 plus x to the n minus 2 plus x to the n minus 3, all the way down to you get x squared plus x plus 1. You can simplify that by writing it as x to the n minus 1 divided by x minus 1. Now what we're going to do is we're going to let x be that 1 plus r over m. Okay, that's what the x's are going to be eventually. So remember, if we let that, basically we're doing everything right except we're missing this p. So if we put a p on front, well, we could have factored out the p and put that on front. In other words, you can multiply both sides of this top equation by p. I'm using p for payment here in this case. And you eventually get this. So this means that, again, if we replace that x with a 1 plus r over m, we find that an annuity has a final amount of, take these payments, 1 plus r over m to the n power. Notice that is to the actual n power, minus 1, divided by r over m. Okay? So let's see how that would have matched up with my idea from earlier. So we had $1,000 payments yearly. 1 plus r over m, that was 1 plus 0.05 over 1. We had 3 years, so my n was 3, minus 1, over 0.05 over 1. Okay? Now be careful how you type this in, all right? Because there's a lot going on here. And it is something to be careful of. So what I like to do is, as I'm typing, I am going to take a sort of step-by-step approach. I'm going to calculate this in here first. So I take 1 plus 0.05, and I put parentheses around that, to the third power, and then subtract 1. And then I hit enter. And then I divide by this 0.05. Now, what we're going to see is it's often nice if you put parentheses around this bottom number. Here we were dividing by a 1 because M is yearly, so M is 1. But it's often nice if you put parentheses around this 0.05. So then hit enter. So we've calculated the top, hit enter, divide by 0.05, hit enter. You should get about 3.15. Now after you've done that, basically what you're saying is you've calculated this entire thing inside the bracket. So now move outside and multiply times 1,000. And once you do that, you get $3,152.50. Exactly what we got before. Okay, so this does match up. Alright, so I want you guys to try this one. A person puts away $200 per month, earning 5% interest. They're going to wait, where they're going to put that money into an annuity, and they're going to do 10 years. How much will they have? Notice that this one is per month, and we're waiting 10 years. I want you to be be aware of that. So take the next, again, push pause on the video, take the next few minutes to try this on your own, and then come back and see if you've done it right. Fingers here. Alright, so hopefully you've tried that. So I'm going to show you how to do this with the formula. Realize that over 10 years, that's a lot of summing if we didn't have this formula. So now that we know this formula, we have a nice go about this. So we have A, that's the amount we want, is going to be 200. That's what our payments are going to be. Oftentimes, by the way, we've called these P's. Other books will call this capital R instead of capital P. Now, we're putting things per month away, so we're accumulating interest monthly. So 1 plus 0.05 over 12 is what I've gotten. I'm going to subtract 1, but before I actually go on, I want us to realize that if we're waiting 10 years and we compounded it monthly, basically that's 12 times 10 or 120 compounding for my exponent. All right? So it's just like in the previous chapter where our exponent was m times t or something like that. I've written the letter n in previous slides, but it's the exact same as the previous chapter. Now we're going to divide this by 0.05 over 12. And again, it's important that when you type this in, you put parentheses around the 0.05 over 12. So what I like to do, again, parentheses 1 plus 0.05 divided by 12. Take that to the 120th power. Subtract 1. I got 0.647. Divide by. Now, by the way, be careful that you don't do too much rounding. All right? So once you've calculated the top, and you should get about 0.647, don't round it to 0.65, and don't round it to even 0.647. Just in your calculator, once you've hit that, hit the divide by, and then parentheses 0.05 over 12. Hit enter. You should get about 155.28. That's what all of this stuff inside the brackets are. And then multiply times 200. So what you're saying is that the amount you'll have in 10 years, if you put away $200 a year, is $31,056.46. All right. So hopefully you got that, and hopefully when you type this in, remember again, it's important that typing things in with parentheses is a big deal. Typing things in correctly is a big deal as well. All right. So make sure that you have all of those things in your calculator correctly. All right, so I want you guys to try this one on your own. Push pause and then try it, read the question, and then come back. All right, so in this case, when we set this up, the amount we're putting away is $2,000 per year at 8% interest. So since it's per year, we're going to assume that this is yearly, 0.08 divided by 1. And I want to wait 30 years. So 30 years, if we're doing this yearly, that means exponent of 30. Take a minus 1 over 0.08 for 1. That's my R over M. And that's what you get. And again, make sure that you're typing this into your calculator correctly. All right. So once you've typed in this, 1 plus 0.08 divided by 1, take that to the 30th power, subtract 1, I got about 9.06. Remember, do not round that in your calculator. Just take that in your calculator and divide by 0.08. 0.08 over 1, technically. You should get about 113.28. So that's what this whole thing is, 113.28. Multiply times 2,000. And if you've done this correctly, I believe the amount you should have after 30 years is $226,000, $566.42. All right. So by putting away $2,000 for 30 years, by the way, that means you would have put away roughly $60,000. In fact, exactly $60,000. With interest, you get back $226,566.42. And this is, again, how the whole thing of retirement works. You put away money, and you continue to put away money on some sort of a consistent basis. And at the end, it turns out that you'll have a good chunk of money if you put away enough and saved enough.